Alright, last time we started looking at triangles, now we're going to look at special types of triangles. Okay, because last time's triangle was pretty random, there's nothing special about this guy, but if we change this triangle to this guy here, okay, where I've made all sides equal, that's what those marks there indicate, then we call this guy an equilateral triangle. Okay, it's because every side is equal in length, but that symmetry also means that all the angles are the same. So remembering that a triangle's angles add up to 180 degrees in total, each one must then be 60 degrees. That's 180 divided by 3. Okay, alright, so we'll leave them off to the side there. We'll make one small change for this other triangle and pull just one corner up. Okay, so this type of triangle just has one line of symmetry running down the middle there. Okay, we call this guy an isosceles triangle. That symmetry line means two things. It means that two of the sides are the same length, and also that two angles here are equal too. Okay, so that means an isosceles triangle has a pair of equal sides and a pair of equal angles as well. But I think it's easiest to just learn to recognize the symmetry, and that should tell you all you need to know. Okay, so let's see some of this in action. It will be another picture where we have to find all the missing angles. So it looks like there's a lot of them this time, but there's a fair bit of symmetry going on. Those marks, again, indicate equal lengths. So we'll hopefully get some stuff for free. So first, if we look at the whole big triangle here, there's a symmetry line running down there because we're told it's got two equal sides. What that tells you is the 40 degrees on the left can shoot all the way across to the other side, and that angle must be 40 degrees as well. Now, this smaller triangle to the left here is also an isosceles triangle because it's also got two equal sides, okay? It's marked to be equal there, and so its symmetry line would run down this way. What that tells us is that these two angles must be the same, but we don't know what they are yet, we just know they're the same. So what can we do? Well, remember, the total angle in a triangle is always 180 degrees, and the angle on the left that we do know has used up 40 degrees already. So if we take away 40 from 180, we get 140, and so we find that the two remaining angles must add up to 140 degrees then. Okay, because that's the only way the whole thing adds up to 180. But because we know that those two angles are the same because of the symmetry, we can share the 140 evenly between them, meaning that each one must be 70 degrees. Okay, great, so two angles to go. Now, if we look across the top edge here, okay, this straight angle here is made up of those two yellow angles that it's captured. So we know that a straight angle is 180 as well. So if the guy on the left is 70 degrees, then the guy on the right must be 110 degrees. Again, to make up 180. So you could have done 180 minus 70 if you're not sure. Okay, great. One more to go. Let's use the triangle on the right here this time. Okay, again, the whole thing adds to 180 degrees, but the two angles we know give a total of 150 degrees. I'll go through this process a bit quicker this time. So that means the remaining angle must be 30 degrees, okay, because in order to make up the total of 180, you need 30 degrees there. Again, you could have done 180 minus 150 if you weren't sure about that. Okay, so that's all of them. That's how we can recognize the special triangles and use their symmetries to work out other bits of information. Okay, thanks for watching. See you around.